So far, we've discussed how ionic compounds act when we dissolve them in water. However, we've only mentioned what happens when we dissolve one ionic compound at a time. But what can happen if we were to dissolve two ionic compounds, each in its own beaker, and then combine the contents of the two beakers? Let's look at this beaker full of water. We'll add solid potassium sulfide here. What is the result of dissolving solid potassium sulfide in water? As we've already discussed, when dissolved in water, solid ionic compounds break up into individual ions, each of which will be surrounded by water molecules. That means that, when dissolved in water, potassium sulfide breaks up into potassium and sulfide ions. We'll once again note that we will have 2 times as many potassium ions in the solution because from the chemical formula, we see that the ratio of potassium to sulfide ions is 2:1. Let's now look at our second beaker, which we've also filled with water. We'll add solid zinc perchlorate to this one. The reaction that takes place is written as follows. This ionic compound will break up into zinc ions and perchlorate ions, each surrounded by waters. The number of perchlorate ions is 2 times the number of zinc ions because, as we see from the equation, the ratio of perchlorate to zinc is 2:1. Now let's see what happens when we combine the contents of the 2 beakers into one big beaker. In some cases, if all of the ions are soluble, nothing happens. But oftentimes there will be a cation and an anion present that will not be soluble when they come together. If the compound that they make would not be soluble, then the ions will also come together to form a solid that precipitates from the solution. Our first rule tells us that alkali metal ions are always soluble, so that means that the potassium ions will not react with any other ions in the solution to form a solid. So we can ignore the potassium ions. They're just going to stay here in the solution. Similarly, our second rule states that perchlorates are soluble. So, just like the potassium ions, these ions will not react with any other ions in this solution to form a solid. Let's ignore them too. The question now becomes, what about the sulfide ions and the magnesium ions? Our solubility rules tell us that all sulfides are insoluble except for the sulfide compounds of alkali metals. They're all soluble. So that means that zinc sulfide is not soluble in water. If it isn't soluble in water, then that tells us that if these 2 ions are present in the same solution, they will come together to form a solid that removes the ions from the solution. They make a precipitate. What is the correct equation for the formation of the precipitate? Zinc ions plus sulfide ions yield zinc sulfide is the only correct way to write the precipitate reaction for zinc ions with sulfide. Notice a couple of things. 1. A precipitate is always the result of an anion and cation combining to form a neutral compound. And 2. The soluble ions, potassium ions and perchlorate ions, are nowhere to be found in the reaction. After all, they don't react. Imagine for a second that there are other things dissolved in the water too, like sodium chloride, CO2 gas, and an elephant. None of these are involved in the reaction either, so we don't write them. A balanced reaction is not a list of the things in the beaker. It's the description of the change that happens. Maybe this analogy will help. A recipe is the change that you do to food in your kitchen, but it doesn't list everything you have in your cabinets. That would be silly. Before we conclude this video, we'll make 2 important notes. Firstly, remember that the rules listed in your textbook are all general guidelines. Other sources will follow slightly different rules because these are meant as a general rule of thumb, not an exhaustive list. Second, while you may see reactions written like this in other places, or like this, you now know why these are wrong. A. Zinc perchlorate aqueous doesn't exist. It exists as separate ions in solution, as we talked about in another video. And B. Spectator ions and compounds don't get included in a balanced equation, just like that 2-year-old can of beans in your kitchen cabinet doesn't get included in your recipe for waffles.